નમસ્કાર, હું આદર્શ છું. વેલકમ ટુ આદર્શ એજ્યુકેશન સોસાયટી. Hello students, today we will study the question number 3 of exercise 9.2. This is the topic of standard 9, chapter number 9, the areas of parallelograms and triangles. Right? So, the question number 3, question is P and Q are any 2 points lying on the sides DC and AD respectively of a parallelogram ABCD. So here we have drawn one of the parallelogram ABCD. One of the point P we have to take on the side DC, that we have taken. One of the point that we have to take as a Q on the side DA. Now here we have to prove that area of APB, area of APB is equals to area of BQC. BQC. Now you can see here that in this parallelogram, if we consider this point, then one of the triangle is formed like this APB, and another triangle is formed is like BQC, right? So as these two triangles are there, we have to prove that both the triangles have the same area, right? So see how we can prove this. Here, if we consider that ABCD is a parallelogram and APB is a triangle. So here we can write down it like this. Here triangle APB and parallelogram ABCD. Right? This is the short form of the parallelogram. We can write it down like this. So triangle APB and parallelogram ABCD are on the same base. On the same base. Which is the same base here? See, APB and ABCD. That means both have this AB side as a common, right? So that will be, we can take as a base for both these triangles and parallelograms. So now this triangle and parallelogram are on the same base, and between the same parallels, between the same parallels. Now, in between which two parallels both they are lying? They are lying between the two parallels AB and CD. AB and CD. So one of the result that we have proved from theorem number 9.1, that if one triangle and a parallelogram are on the same base and between the same parallels, then we can write down that area of APB, that is the area of triangle, is equals to half the area of ABCD. Right? So area of triangle is equals to half the area of triangle. Right? Parallelogram. So give it the equation number 1. In the same way, now think about this triangle BQC. So we can write down again that triangle BQC and parallelogram ABCD are on the same base. Now see which base we can take. BQC, this triangle, we can take BC as a base. So ABCD, for this parallelogram also we can take BC as a base. How is it possible? First time we have taken AB as a base, now we are taking BC as a base. Actually, all the sides of a parallelogram we can take as a base, right? So first time we have taken AB as a base, now we are taking BC as a base. So for both this triangle BQC and parallelogram ABCD, now the same base we can consider as a BC, and both this triangle and parallelograms are lying between, are on the same base and between the same parallels. Now in which two parallels both they are lying? BC and AD. Yeah, right? So BC and AD. So now again this kind of result here we can write down that area of triangle BQC, area of triangle BQC is equals to 1 half the area of parallelogram ABCD. Give it the equation number 2. Right? So now we can compare both these equations. Right hand side we have 1 half area of ABCD. Here also we have 1 half area of ABCD. So these two parts will become equal. So from equation number 1 and 2 we can write down that area of APB is equals to area of triangle BQC, right? And that is the required result that we want to prove. Area of APB is equals to area of BQC. Okay, so this is how we can prove this sum. Now let us treat the question number 4. Here we have given one of the diagram. In the diagram, ABCD is a parallelogram. P is the point in the interior of a parallelogram. So P is the point anywhere inside the parallelogram ABCD. So ABCD. So we have considered here that the point is here. Now from this point we have joined A, D, B and C. So the first thing we have to prove is that area of APB. First thing that we have to prove is area of APB plus area of PCD. PCD is equals to 1 half the area of ABCD. ABCD. That is the first thing here we have to do. Right? So here, if we want to consider the triangle APB and PCD, then PCD is here, APB is here. So let us do one thing. Draw a line through this point P. Draw a line through this point P, which is parallel to AB and DC. Let us give it the name. Here we can give it the name E and F. So now ABCD is a parallelogram, EF is a line which is parallel to DC. So what is the thing here happen is AB, EF and CD, all the three lines are parallel to each other. So two parallelograms are formed. ABFE is also a parallelogram and EFCD is also a parallelogram. So here ABFE, ABFE and EFCD are parallelograms. Right? Both are the parallelograms. Now the same thing as we have done here, we have to apply here. See, the triangle APB and parallelogram ABFE are on the same base AB and between the same parallel AB and EF. Right? Why we take the base as a AB? Because for the triangle this is the base. So we can take the same base for the parallelogram. So here we can write down that for triangle APB and parallelogram ABFE are on the same base, which is the same base AB, and between the same parallels. Right? Which are the same parallels? AB and EF. AB and EF. So now, according to this result, we can here write down that area of APB is equals to area of ABFE. Right? Give it the equation number 1. Okay. Now we have to here two areas APB that we have find out. Now let us find out the area of PCD. Okay. So okay, 1 half we have to put here. That area of APB is equals to 1 half the area of ABFE. Now consider this triangle, triangle DPC, triangle DPC, and parallelogram EFCD. EFCD are on the same base. Now, which we can consider as a base? DC we can consider as a base, same base DC, and between the same parallels. Which two parallels we can consider here? EF and DC. EF and DC. So now again we can write down that area of DPC is equals to 1/2 area of EFCD. EFCD. Give it the equation number 2. Now if we join both these equations, if we add both these equations, then what will happen? Let us add equation number 1 and equation number 2. If we add both these equations, left hand side is added with the left hand side. So area of APB plus area of DPC. Here we got 1/2 the area of ABFE, area of ABFE plus 1/2 area of EFCD. EFCD. Right? Now just we have to keep this left hand side as it is because that is the we required. So area of APB plus area of DPC. Here we can take 1/2 as a common. If we take 1/2 as a common, here we get the area of ABFE plus area of EFCD. EFCD. Now see, add both this area. ABFE means upper parallelogram, EFCD means lower triangle. If we add both this area, we get the total area of the parallelogram ABCD. So here we can write down that 1/2 area of ABCD. That is the required result. Right? Area of APB plus area of DPC is equals to 1/2 area of ABCD. This is the first result that we have to prove. Now the second result we have to prove is that area of APD, area of APD plus area of PBC. PBC is equals to area of APB plus area of PCD. Right? So see, that is the thing that you have to do. How we can do these things? See, first of all, whatever the things we have to do here, that the same thing we have to do for the second term. But here we require the area of APD. So APD is this triangle and PBC is this triangle. So as we have done two parts like this horizontally, now we have to do the same part vertically here. So if this is, we can take P as a point. From here we have to draw a line. We can give it the name like G and H. So again here two parallelograms are formed here. One is AGHT and one is BGHC. Right? So here we can do one thing, that triangle APD and parallelogram AGHD are on the same base AD and between the same parallels AD and GH. Then we can write down this kind of first result. The same thing we have to apply here. You can get the same result like this. When you add both that result, you get the same kind of this result that we get here. But at that time, left hand side you get the area of APD and right hand side you get the area of PBC. And right hand side you get 1/2 area of ABCD like we get here. Then when you compare this result and that result, then you can get this result. Okay, so this is for you, right, to do. So this is how we can solve this type of questions, right? This is all about this lecture. Thank you.
Thank you for joining us.